So this is a video log. Let's see, we are October 8th, 2020. I'm discussing the model here I'm going to call the Earth Crust Tidal Flow Harmonic Resonance Mantle Simulation. This is actually a simulation using particle physics. In the model, for the record, there is no gravity acting. It's vortex forces acting on a particle system only, and there is one harmonic resonance force at the center of this model. In the model here we have 12 vortex forces. I'll highlight one of them so you can see what we're looking at. So there's the direction of them. And if I highlight them all, we can see that they make effectively a tetrahedron or tetrahedral form, which is discussed in more detail in the paper called The Geometry of the Proton and Tetrahedron, written and co-authored by Jeff Yee and Terrence Howard and myself. So for more details, you can see that on ResearchGate, and the paper is called Geometry of the Tetrahedron and Proton, by Jeff Yee, Terrence Howard, and myself, Chris Seeley. And let's see, and then we'll go here. Let's see. So in this model, the vortexes are all active forces, each with a value of approximately 1. Unitless, it's just unitless. And you can see that they're opposed to each other on the face around a form that Terrence Howard refers to as the linchpin. And I use that as the guide as to where to put the vortexes. So they're following the linchpin form, which looks like this. So you see that it's a tetrahedral form. Like so. And inversely, it is proportional to what Terrence refers to in his book as the awl shape, which is this shape. And the awl shape points to and identifies, if I look at it on an angle here, you can see that it's pointing to where the vectors of the vortexes converge at this vertex point here, coming out of the screen, or out of the screen towards the viewer. And that is consistent on all 3 sides, or all 4. It would be 4 points in 3 dimensions. And the bottom, same thing. The blue dots are the particles in the system. With mass. And I'll just turn that off. So those geometries are there to guide where to put the vortexes and how to angle them, and their trajectories of their, I guess you would call it the vertex, or the vector, force vector to be more specific. Now I'm going to turn on, well, let's just run that for a second and you can see what happens. So there's an instantaneous impulse when the forces start to act on the particle system, and they converge into a sphere with the vertex points trying to become hollow as a repulsion or expulsion, like they're pushing outwards. Let's make that a little more centered here. So pushing outwards towards the viewer. So like we looked at before, at those points you get 4 points of divergence in the spherical harmonic system. So far so good. So that's the basic geometry we have. in this simulation. Again, there's no gravity, and it's purely a physics simulation using particle physics. So no animation. It builds itself based on the physics. Now, where it gets really interesting is when I run that. As compared to a map of the Earth. And we follow the harmonic nodes over time. Now I just want to go back here and show you a few here. So as this is a time evolution, so what happens is when it first starts, you can see that it kind of started here in historical sense. There was a harmonic node here and this line going across the surface in the Himalaya mountains, created this range here. And there was a focal point at this node, which kind of disrupted, and this lake is located there, which is in Europe. Okay, so we'll just kind of scroll around. I can show you where some of the very, very early harmonic nodal points would have been as the crust first formed and started to solidify, coming out of phase transition. So they're pretty much where you'd expect them to be. Great Lakes, Canada, North Pole is separating and diverging, while the South Pole is converging and collecting over time. And it spirals, if I get it going here again. Right, and you can now start to see the reason for that focal point right about there, in between South America and Antarctica, as a strong focal point. Right there. Right, we can see that path is actually being traced by the harmonic waves. And in the future, it'll be probably over here somewhere, probably where it was before at one time, way, way back in the past. So it seems to repeat itself, possibly. Now, going back here to the Himalayas, this is a really interesting spot. So we go back to the start. So there was our first start balance, and then it evolved over time. And it looks like it stopped here for quite a long time and developed these harmonic nodes and brought that formation of the mountains into existence. And the rest of the harmonic nodes are following the topology as the Philippines develops. And we can follow that. If I just hit play here, you can actually follow it over time until you get into a more modern day type of scenario. And it takes quite a while, actually. You get a really nice match here after a while. Right there is pretty good, but so I'm waiting for this node, the node here that's at the bottom of Australia, to make its way up here and collect it, converge at this point here, which is where I'm hypothesizing that, because these 2 points will line up, right? You get this harmonic node converging at this point here, and the second one converging at the island string on the far left-hand side. So we can kind of see how the nodes, as they move, like they may stop for a while and converge, and then, you know, the system might be at rest, and then you get a lot of, you know, formations happening. And then they probably cycle and start up again. You know, the freeze-thaw cycles, ice ages, right? It would be at rest for 100,000 years. Then you get, you know, subterranean, lots of activity and volcanic eruptions and major rapid shifts. They probably come in fairly rapid cycles, I would think. Sort of like if you're jumping a node or harmonic node in music, or say an orbital in the case of charge relative to electron and proton exchange. Electrons jump orbitals, the same as the crust would expand and contract relative to charge. I'm just going to stop it right about there. That's not too bad, I guess. I like it a little closer, but there you go. That's about right. So then we can zoom in and you can see that how accurate these lines of force are drawing out the topology that we actually observe on the surface, and where things end up, and where they're being spread apart, right? So it gives us a reason as to understand why, India tends to be viewed as heading in that direction. Well, it's actually being kind of broken up and lifted and pushed into the downward forces coming from the north, and it's sort of converging on the outside of that rotating force, because there's a pivot point right there, right around, I guess this would be the Mediterranean, right? Indian Ocean. And then these points mark a few little interesting locations too, like the where the Eye of Africa was historically, right about there somewhere. And we can roll back and see why some of these were where they are over time, right? You can see that a harmonic node at one point lined up here to create this volcanic uplift. It used to be an old volcano, I would assume. And it used to be one here, right about there in this region. If my little cursor can show up here, let me turn it on. There. So this region here I'm referring to was somewhere around this harmonic node, and then later it paused here for a while, long enough to create this formation. Separated out the Mediterranean through here, Strait of Hormuz, I think is what it's called. If I said that wrong, I apologize. But you can see how this node swept down through here and eventually took its residence in the Congo. I guess this one actually swept upwards, but you can see it's pushing that coastward, that coast of Africa, and the Horn is literally being driven that way, while simultaneously Madagascar at this harmonic node here now is being driven the opposite direction, a push-pull resonance system. And we got a nice node here in the South Atlantic, i.e. the South Atlantic anomaly, which is now on the move, right? There's a connection point at this harmonic resonant node and down through this current into South America. So there's a really strong anomalous current in this zone, pushing in both directions, opposite itself, driving South America westward while converging on the coast to create the mountains. Right? It's pushing, always pushing here, and it's harmonically resonating at the mountains to create the ridges where your piezoelectric materials will gather. Granite rock, granites, quartz, etc., being a piezoelectric discharge, and capacitance. And Hawaii is another one that's quite interesting, which is, yeah, oops. Hawaii is kind of cool because it's obvious that Hawaii has kind of always kind of been there. It is at a harmonic node at the very beginning, so a strong volcanic, probably early on. It's been there a long time, and then it's been reinforced over time, where it's converged on it again here as it comes back around full circle, while simultaneously driving these islands and the Emperor's chain to diverge from itself. Right, it's twisting and pushing that island chain that direction, and pulling the other one south. So let's see what else. This is the same. So now I'll just stay in this position for now. It's not too bad, I guess. Yeah, right about there. That's all right. So this is the same map of the Earth, only now we're looking at the red represents gravitational anomalies on Earth. So where the strongest gravity is red, and the less gravity is in blue. And again, we see that it's in alignment where the hollow spots are the less gravity, where they're rotating around and breaking apart the crust, and higher gravity where the mountains and so forth are converging. And it's consistent throughout the model over time. These things settle into place. And also, I'll turn that one off. What we've also noticed is that in the holes, in the zones where it's rotating, it actually seems to disperse hurricanes. These blue lines are all hurricane paths, historic hurricane paths, I think for 200 years, I think is what the map I got. So it shows where they track, where they charge up on land, coming out of South America, in this case, up through Mexico, charging up and converging on this harmonic node here off the coast of, south of Baja, off the coast of California, basically near Mexico. Charges up here, and they actually launch from the coast and head westward, avoiding the hole. Sometimes they get whirled around the hole, like they come into this negative zone and then swirl around and roll back on themselves, because this is twisting like a vortex, right? And it will pull them around. And if they make it through that, they'll actually focus and intensify, picking up energy at the harmonic nodes headed westward here. They'll gather energy and build until finally converging back to ground in the Philippines and I guess it would be the east coast of China, South Korea, and all in there, Asia, South Asia. And that is consistent around the entire planet. As well, in here is a really important one. This is effectively the same thing, and this is your Bermuda Triangle. So it identifies the Bermuda Triangle with the tip of the all shape. If I highlight that again, and I'll scale it, you can see that the point comes right out through the Bermuda Triangle. And this is the general planes of inertia. Which identifies the circuit. I'll just scale that up a little bit. So this is in general, this is very general, but in general speaking, general terms, the Earth is functioning as a liquid filled or liquid surface, oil filled, iron rich transformer. That's on the large scale. And basically that is, let's turn this off, turn that off. Okay. Let's go turn off that sphere for a second. So when we look at it in, on the macro scale, it's a planet. And when you look at it on the micro scale, it's effectively an atom, a single atom or a molecule of charge. Very similar function, where the shell essentially divides itself up and separates materials relative to charge density and velocity in a rotating reference frame, like a gyro. I'll just move this to put the cursor back to the center here. It's always my nemesis. So let me just select those again. Take a closer look. So geometrically, that is the tetrahedron, all shape, proton, Earth. So for more information, again, see tcotlc.com, which is Terrence Howard's book on this subject and more, and also Jeff Yee's website, energywavetheory.com. I believe that's what he has it as, or ewt.com. It's Energy Wave Theory by Jeff Yee. If you look him up, you will find some more details on that. And this is a model and animation, well, not animation, a model and physics simulation of that system. Thank you very much. Have a great day.